Hi, let's have a look at the answers to question 7, all related to map G in your Theme 14 booklet. The first question asks you to describe the texture of the granite that's shown in photograph G. Like all igneous rocks, it has random interlocking crystals. It's coarsely crystalline. You can actually measure the size of these crystals. The grey ones are going to be about 4 millimeters across. The pink ones there, 12, 15 millimeters across. Because we have a mixture of crystal sizes here, we've got some very coarse crystals, some less coarse crystals. This is porphyritic. Now we can tell that this granite forms a pluton. It's very large, cuts across the bedding, it's irregular in shape, and it's full of this very coarse-grained igneous rock. It must be a pluton. So we can see the shape from the map and its relationship to the rocks, and the fact it's coarse-grained means it's very slow cooling that's formed this rock. Okay, if we identify the minerals now in the mineral vein, we've got two. These minerals are galena and calcite. The grey mineral with the 3 cleavages and is quite soft uh, is galena. That's lead ore. The white mineral, though, that's softer than a copper coin, fizzes with acid, must be calcite. Now, this mineral vein we can see is coming off the granite. So, where we get veins of minerals related to igneous rock, this is going to be the result of hydrothermal precipitation. Hot water being injected into the surrounding rock. That hot water has lots of dissolved elements in it that when the hot water cools down, it'll precipitate them, it leaves them behind. Okay, question C asks about a metamorphic aureole related to the Pluton. And it tells us it's 100 meters wide. So for this question, we need to measure 100 meters on the scale that's shown on map G, out from the edge of the Pluton, and we mark in our symbol like that. So the area inside that line, in between the line and the Pluton, has been metamorphosed. We also know these rocks have been folded, so we need to use the correct symbol to draw a fold axis here. We can see that the 2 dip arrows here are pointing towards each other, so this is a syn form, and we draw the axis there in the middle of that fold, where there's a bit of symmetry. We then need to think about the geological history of this area. This is the history, starting with the oldest rocks. Those are that's the breccia, we can see in the far north and the far south. Remember, rocks get younger in the direction of dip, so the breccia must be first, followed by the sandstone, then the shale, and finally the conglomerate. Those sedimentary rocks then have been folded, so the second main event is the folding. And finally, the granite and the mineral vein have been intruded into those rocks. We can see that the granite hasn't been folded and is cutting across all those other structures. So it must be the youngest thing. Finally then, those of you that dug deeper, that fold isn't very obvious on the cross-section between X and Y. We can't see it. And the reason for that is that the cross-section is actually following the strike of the beds, not the dip of the beds. And if that's the case, those beds, doesn't really matter how steeply they're dipping, they're always going to look horizontal. If you have any questions about any of that, do get in touch. I'll see you then.